Yeah. So we should be live right now. Okay.
Okay.
So pretty much working on the same scheme. So we're going through the reviews that I send you. They're all around missions about contextlib, AST, and heapq, right? So
Yes.
they all ran. They're all sorted by rank that users gives to the solutions, and after the video, after the whole video podcast, I'm doing like the short video of the most essential, most interesting part of what we heard from this code review. So users can ask questions in the video, in the YouTube video channel, or in the comments. So, and I may ask questions as well, since I go through some.
Okay. You will relay those questions to me, or I will read them somewhere, or
I will ask you. I will reread.
Okay.
For you.
Okay.
Yeah.
So let's start. Right.
Yeah. Have some fun.
Okay, so for the ones that have been looking at these videos already, this is some kind of a new format where I don't concentrate on various ways to approach the problem, concentrate on some mission. I concentrate on the using of some of the Python batteries from standard library. And Alexander has asked me what modules I think will be appropriate for this kind of review, and I said probably contextlib, and I saw some solutions using AST, abstract syntax trees, and I was very interested in what people were using from it. In fact, there is only literal eval function that is used on Check.io, probably because people are scared of eval. But I will speak about it later. For now, let's concentrate on contextlib. And the first one is mine. Oh, thank you very much. So what is this? This is a solution of a mission, what is wrong with this family, where I need to sort out whether some kind of family tree, some kind of mapping from sons to fathers is really a family tree, and which ones are not. And I do it in a very creative way. If I say so, the title gives it away pretty much. It is the theme is exception mishandling, because of course exception handling is boring, and we all know what it is and what is exception mishandling. What do I do here? Let's just jump through it. I first create a real mapping, a Python dictionary from it. I just iterate through the tuples, and I assign the father to a value of son, and then I for some person I define a function to give the oldest ancestor, and then I pick up all the roots in that tree, that all of the oldest ancestors of everyone in this mapping. And if there is only one root, then it is a family tree and not a forest. But how do I do it? If you look carefully, you will see that in this case, I first assert that son is not in F. Assert is one of those Python statements that, let's see how this Jupyter thing works. I can assert something, for example, 1 + 1 = 2, and Python will do nothing. But if I assert something that are not true, for example, 1 + 1 is 3, I will get an assertion error. And that is practically ordinary exception that I can catch and I can handle it in some way. Here I use it in a creative way to get out of this function as soon as I encounter an exception and return this false. How do I do it? Of course, I can do it with try except, but I can also use a very handy function from contextlib that is called suppress. For example, if I from contextlib import suppress.
You can use tabs, by the way, in Jupyter. So
I can use what?
Tabs. So you don't need tab everything.
Okay, how do I make a new tab?
No. I mean you can type from context and tab and.
I can autocomplete. Okay,
yeah,
okay.
Sorry, yes, this is the more correct.
Yes. I meant tabs, like in those tabs. Okay. So I have imported suppress, and if I say with suppress, I don't know, assertion error. I can assert something false now, and I'm protected.
So it's like break, right? Or go to.
Yes, if I just get out of with now, it will be useless. But if I do something here,
okay.
Then it will, of course, yes. It is. If this were a loop, then it would be a break. But of course, it isn't a loop because I only do one pass. Of course, I can always say for something in a range of 1, and then I will get a loop which I can break from. But it's kind of weird. And of course, this is also weird, but it is according to the theme of exception mishandling. Because I also mishandle some other exceptions. For example, while I am calculating this oldest ancestor, I am using a recursion. But of course, while I'm using this recursion, it is perfectly possible for some person in the table to be its own father. Of course, in this case, I want to return false, but Python in usual sense would just recurse infinitely. But of course, Python has a shield that protects users from infinite recursion, because it would overflow the stack and users would get kicked out of the Python interpreter. Python has something that's called recursion limit. Get recursion limit. So this autocomplete is weird, but okay. And it is in modern Pythons, it is usually set to 1,000. What is it for? If I write a recursive function and get careless, for example, I will just call it right away, and then I okay, now I get a recursion error. And what do I do here? I suppress this recursion error. So if this function recurses indefinitely, it will raise a recursion error, and this suppress will break out of this, and it will return false. However, there is one more thing going on here. I have a nested suppress. Why? Because, of course, if you look carefully, you will see that this function is really recursive. It has no base case at the first sight. It has no, if something is true, then you just return something, and otherwise you recurse. You recurse always. However, you are protected with this suppress. If you get a person which is not in this mapping F, this access by itself will erase here. This suppress will then not evaluate this oldest ancestor, and it will just return person. So it works. It works nicely. However, of course, if there is an infinite recursion, then it will throw an recursion error, and function will return false. So we also see that this suppress can be nested. I have a suppress inside a suppress, and it works very nicely. That is mostly it. Yes, then I just need to see whether there is only one root in the tree, and that's it. I could do also this with assert, but this was simpler. Okay.
Yeah, that's sweet.
Let's do another one.
So in general, when you want to to use this this trick, right? So if you want to like break the ordinary workflow and just jump to the end of the function, you can just use with, suppress, and some.
Yes. It is made for a very standard idiom that was very common in Python 2. When people would write try to do something. No, right. No. Let's see if I just. Okay. You try to do something, and except something happens, you just pass.
Yeah.
This try, accept, pass. This kind of thing that's used very much. You can more easily write it with using suppress some exception.
Yeah.
And then okay, I keep pressing shift enter instead of enter, but yes, something like this. Okay, there is one more nice thing about this. I think I should say something about it. People usually when they write this first kind of thing, they usually out of laziness or out of ignorance or something write something like this. And then pass. This is very some bloggers say that it is the most dangerous idiom in Python, because you're thinking that you are catching some kind of exception, but instead you are catching everything that could happen, and that doesn't only mean the things that people would normally think about as exceptions, but also name errors. If you misspell some name, Python will raise a name error in the hope that it will be reported, but it will not be reported. It will just be swallowed and ignored. And of course, some other things like, for example, someone could press Control-C to break the execution if it goes too long, but Python handles it as just an ordinary exception. It is a keyboard interrupt.
Yeah.
And this except will just swallow it, and some other things also. So it is very weird to use it if you have in some. Sometimes you have a bug and Python starts to react very strangely because you haven't seen anything like this. There is a line in Zen of Python, of course, that says errors should never pass silently unless explicitly silenced. Of course, this kind of counts like an explicit silencing, but it is very easy to use, because if you just don't write anything after this except, it will work. On the other hand, suppress doesn't work that way. You have to write some exception class here. So you have to think about what exactly do you want to suppress. There is one more thing that shows really nicely how Python is cares very deeply about how some things are named. People probably don't know that in some beta versions of Python, this suppress was called ignore. So it was contextlib.ignore, and it was working in practically the same way. But it was noticed during beta testing that people were constantly misunderstanding this about if I write with ignore some exception that I will just call A, and then I will call B, and if A raises some exception, it will just be ignored and it will proceed to B. Very wrong to think about it in this way, and there was much discussion in Python mailing lists and on the bug tracker about a new name of this ignore, and it was practically a consensus that it should be renamed to suppress. So now it is a suppress, and it's probably more understood, but still relatively not well known.
I have a question. Since we were talking about try, except, pass, when we just avoid any exception, I was always wondering why Python don't give some warnings or something that says, "Oh, you forgot to put exception."
It is a really nice question. I have wondered this also in many occasions. There is, of course, you can also always write exception, and it is kind of a base class that contains most of the things that people would like. However, it doesn't contain, for example, keyboard interrupt or system error or some weird exception classes. So instead, you need this. However, even this is not perfectly okay. However, why? Because when you need to when you really need to have something like this, it is probably in some occasion when you are writing a server or you are writing an I don't know, embedded system or something like that, when you don't really want to risk something happening and you don't enter this except handler, right? And what can happen? This base exception. It looks like something fundamental, but it's not. It's just a name. You can in some other kind of code you can write I don't know, and you will defeat this mechanism, right? Of course, nobody will do it intentionally, but for example, I can write a class. Some exception that derives from base exception, and I can just have a brain malfunction and just swap these ones. I have seen people do this when they derive some class from another class. They just instead of writing class A in parentheses B, they write the class B in parentheses A. It's weird, and you think it will never happen to you, and then it happens to you. So you can write something like this, and you will defeat this mechanism, because in this case, this basic exception will not refer anymore to real base exception, but it will refer to some class of yours. So this is really a sledgehammer. This really means except anything that could possibly happen, and I don't want to even think about the ways to defeat it, because that there shouldn't be any way to defeat it, except is a keyword, right? For example, I can use some other keyword, or probably if it was designed in Python 3, people would probably write something like this, or but it stretches all the way back to Python 2, when it was even more complicated, because not every exception was a base exception. People also probably don't know, but in Python 1, exceptions were not classes. Exceptions were strings. You have raise. Something like this, and then you caught it with except, and then you had some things in sys module. I think they are still there. XC info and accept hook and some things like that that you can and also sys I think last traceback, last type, and last value. You see, for example, it is practically useless in nowadays to have separately last type and last value of an exception, because of course value is of some type and its type is just an exception type. But in the olden days it wasn't so. You were raising some things and some strings together with it. So the value was a string and the type was some kind of an constant. So yes, from these days, except was very fundamental, and now people are just afraid to get rid of it, because it really means a strong commitment to catch everything. But of course, there are some people that say that it has its use, but it shouldn't be written so easily. So, of course, as a workaround, we now have a suppress that you really must write. I think you must. I'm not sure what happens if I. No, I can actually suppress nothing, but of course it doesn't suppress everything. It just suppresses nothing, because of course I can suppress some exception and some other exception. So it just receives star arcs probably, and of course if you don't pass anything, that it will just do nothing. Okay. Must write something. Okay, so of course this is not the same as this. This catches everything and this catches nothing, and it is more intuitive and much less dangerous in this way. Okay, another one.
Yeah, let's do it.
Okay. Good radix, and the title is The Good Solution. It is probably also mine. Yes. So a mission is some kind of a mathematical thing. You just have to find the least base that will satisfy some division criteria, and it is just simply this. You just, of course, you have to have some criteria of good base, and the base is good if the number written in that base is divisible by base -1. And you just write it in this way. Of course, the very nice way to write divisible in Python is just to have not A modulo B. That means that A is divisible by B. It should be noted that in some other languages this is not possible, because not is simply another operator, and it's its precedence is probably wrong in this case, so you have to write something like this. For example, in C you must write this. You cannot write this because this will be interpreted in this way, and it is just wrong. Python has much more precise grammar that allows you to write some things like this, but of course there are some disadvantages about it, because not is really a keyword and it has a special place in the grammar, so these things would work. But for example, these things will not work. Invalid syntax. So you cannot really write not here and expect it to be of a high precedence, because not is special. There are some keywords that can be combined with not. For example, is not or not in or something like this. But in most cases it works fine. Of course, you can write, which is really important, because and is also a keyword, and they understand each other perfectly. Okay, so I just write this, and it doesn't really work. Why? Because this int number base might raise an exception. It might raise an exception if there is some digit in this number which is not valid in this base. So I just wrap it in a suppress of value error. It raises value error, and I say if it raises value error, then don't mind it. Just continue.
Yeah.
And that's it. In this case, of course, this good function will continue. It will find out that it has come to an end. It will return none, and it will not be true. It will be true, so the filter will go on. And I just pick up from range of 2, which is the lowest possible base, to including 36, which is the highest possible base, because of course the bases use numbers and letters from English alphabet, and 10 plus 26 is 36. And of course, when I need only one, I can use filter, and I can use next with it. But if there are no good base, the task says that I must return 0 or something like this. Yes. Where? I'm not quite sure, but there is probably some test or something like that says that you have to return 0 if there is no good base. So the next function, as we know already from reviewing Guido's solution, can accept a default which will be returned if this generator doesn't yield anything. Okay, so it is just another use of suppress.
Yeah, I'm just trying to remember all my some of my solutions where I when, for instance, where I just try catch value, and when
yes, you just write accept value error, pass, and that's it. But when it is just a one line, it gives you some nice ways to think about your solution. For example, how it really interacts with a real loop. You say it is kind of a loop that loops only once, but it has a break. But you can, for example, write something like this: for I in something, and then with suppress some exception, you do something. What will it do? If this do something, raises this kind of exception, some exception, then it will just continue on the another iteration of this loop. So it's not like a break, it's like a continue, in fact, right?
Yeah.
But if you write this with suppress some exception and then for loop, and it is in reverse. It is really like a break, because of course if do something raises an exception, this whole for loop will just be abandoned, and it will continue here. Right.
Yeah, that makes sense.
So you can easily switch. You can easily see the duality between break and continue in this way. This is just a for loop after which you suppress, and this is a for loop before which you suppress. Okay.
Yeah.
Right. So min and max, third solution. What is this? It has a partial and it has a suppress, and it's not my solution, so it's nice. So what is okay? It uses a suppress in some nice way to unpack those arguments, because of course min and max are those kind of special in Python about its usage, because Guido was very unhappy about it, but with time he has learned to just live with it. Because, for example, if you have some other function, for example, sum, you cannot really say let's sum these ones, because of course it will raise a type error. For max you can. Why? Because there is kind of a reason. A reason is that with the first one, you have a binary operator. You really can just do this, and it will sum them. Nobody will use sum for something like this. Though for I have seen people write, for example, for strings, join I don't know, A and B instead of course A plus B. But of course those are just slight brain malfunctions. For summing, probably nobody will do it. But for min and max, you don't really have this analog. You don't have this binary operator that will give you the greater value of two numbers or two objects, or the least the minimum value. So you can use min and max in this way. You can use max of A and B as some kind of a binary operator. And of course, it collides with the idea of using max or with some list or some other iterable of objects. But fortunately, this collision of semantics is not really important, because of course when you do have one argument of maximum, it is just the same object. So of course it doesn't really work, but this kind of function is useless if you view it as in this semantics, when you have a binary operator max, and then you try to devise a unary operator that will do the same thing. It is just identity. If you just so it is much more useful to do it by cases. If you define this, and if len of args is 1, then you use this semantics with a list. With I don't know.
This is what we usually see in solutions.
Yes, and if it is greater than 1, then you use this semantics as an operator, and it works very well until you need to actually implement it, like in this mission. So you need to have some way to branch in those two cases. Of course, you can just write an if that will whether the length is is 1 or greater than 1, but you can much more nicely write this contextlib suppress. How? You just suppose this args is of length 1 and try to access its only element. This is a special case of unpacking. If you write I don't know of course some iterable is 2, 4, 5, and then you say x, y, z is it, it will just unpack it. So y will be 4. However, if it has only one element, it will be written like this. Of course, you can use parentheses, but parentheses are not necessary in the same way as they are not necessary here. So you can just like this, and by analogy, when you unpack it, you use this. And x is 2. So you try to unpack it. Of course, if it's not of length 1, if it is, I don't know, 2 and 4, and you try to unpack it in this way, you will get value error. In this case, you don't have to do anything. These args will be perfectly well suited for this sort of function. However, if not, then this only item in args will be suited for sorted functions. So you just name it args. So this, in case you don't do anything, args will be fine. And in case length of args is 1, then it will not be args anymore, but args will be its only item. And in both of those cases, sorted knows how to do with it. It will just make a new list with its elements sorted according to this key. And also according to this reverse, which is, as we see, first argument. Why first argument? Because then it's much easier to write a partial when you when you define min as a partial of this function which passes the first argument as false, and max as the same partial but which passes the first argument as true. And you avoid the duplication of code in this way, because it's not a lot of code, but still it's nice to see that it can be written as just one function, because those functions have the same code, they just have different values here in the reverse. You write reverse is false or reverse is true, and you pass it as a first argument. Okay.
Okay.
Another one.
Let's see. Is there any different
size block formally? Contextlib. Oh, it is just a it is just a suppress, but it is a suppress of zero division error. And what is a zero division error? So it divides here. Why it divides? Because I need to. Oh, this is really heavily using standard library. It uses contextlib, collections, iter tools, and func tools. It's just only the operator is needed for the whole picture. But yes, func tool wraps. It uses it as a decorator or something like this. Yes, normalized points. So you. It's nice, but of course, when you just write your own function, then you don't need to write it as a decorator, because it is used only once. You can just write it in this way, but probably the author was trying to be his knowledge about many things in Python. I think I remember this author. I was leading very interesting discussions with him or her. I don't know. about the nature of Python, philosophy of Python, and some things like this. But I just need to. Yes, this is one of those mathematical arguments when you need to. I don't know if this is not normalization. This is solving the system. This is using the linear systems theory to find out whether the intersection, whether some line passes between 2 points. So if you need to check whether line passes between A and B, you intersect P with AB, and then you parameterize this AB so that this A has really a coordinate 0 and this B has coordinate 1. It will give you a T with some coordinate, and then you see whether this coordinate is between 0 and 1. However, in this, if you are solving this system really in a really naive way, then this division will of course be possible to be a division by 0, because this is some kind of a determinant, and if P is parallel to doesn't work if P is parallel to A. But in this case, of course, you probably don't want to consider it as being between A and B. So in this case, the author just suppresses this zero division error and doesn't care about it. Of course, here if this parameter, this coordinate, is between 0 and 1, then you yield this point. But of course, if suppress catches the 0 division error before, then you don't yield it, and you just don't consider it. Okay, so from contextlib, it is a usual thing, but it uses very nice things like name tuple and decorators, functools, wraps, and iter tools. Oh, take while is also nice. So it is all over the map. Okay. Let's see what's this. What's wrong with this family? We have already seen this, but it probably uses suppress in the same way as I did, but it probably doesn't use anything. Oh, it is my solution, right?
That's yours, yeah.
So why has he done it? It's interesting. And how has he done it? Has he seen my solution without solving the mission, or has he solved the mission in some other way and then liked my solution much more?
Yeah, that might be the case. The second one. I haven't seen that someone's.
Yes, I'm not angry or anything, but I just think that there should be some way to report some things like this, because
yeah, this is a report.
Of course, the thing is, my solutions are recognizable. When you look at this, you just see. probably not everyone, but many people on Check.io have learned to recognize my solutions. I think I have seen in some random review a comment. This came through random review, but it is probably Veky's solution.
yeah, I saw this. Yeah, that was so.
And yes, it was my solution, of course.
Yeah, they have in missions, when missions just fresh new missions, we just put the constant random review. So people can only do a random review until it becomes.
It's kind of a nice way to uniformize those reviews when in the beginning phase, but yes, there is still that problem that you have, I don't know,
But I agree.
200 solutions and you cannot really review them all. But well, some kind of machine learning or clustering is needed when you really can automatically say those, I don't know, those 10 solutions are really different than all the others, and then you just review those.
Oh, this is interesting.
But machine learning is not really yet in this phase that you can really do it. So it is also my solution. It is just of deduplicating your code. It is nice to think about generally when you do something about I don't know, number 3, boolean true, string a, and something like this, and then you after it you do the same thing, so the same code, different data about I don't know, number 1 boolean false, string b. You can duplicate it as usual with partial functions or with auxiliary functions or something like this. But in Python, you can also deduplicate it by just using a loop. You can loop can loop through anything. So you can say for x, y, z in 3 true a, comma 1 false b, or whatever is changed in your code. So you just look at the code and see what has changed, and then you loop over it, and then you do something with x, y, and z.
Okay.
Right. So that kind of thing is used here. So you just see that you define the function 2 times. You define a minimum and you define a maximum. So you have 2 defs. But of course you can do it with 1 def in a for loop. So it is really kind of obvious. However, it's not really obvious, and it is a reason why I have written this solution, because Python has 2 things working against this philosophy when it is about defining functions. Which are those 2 things? First is closures. Python argument passing is such that you functions are really just delayed code. You write some code, and it will not be executed immediately, but it will be executed when you call that function, of course. However, if that code refers to some variables, for example, this args or this key or this, I don't know, whatever those arguments are, the values of them will be in the time of execution, in the time of call. Mm-hmm. So you really need to freeze the value of I. For example, this I just goes through enumerate of min and max, so indices, so just 1 and 0. Of course, here used as true and false, but you cannot really write blah blah reverse is I. Why? Because this I will, in the next pass of for loop, it will be 1. It will not be 0 anymore. And when you call this function, this closure will refer to this I, which will have the value 1. So it works, this kind of deduplication works if you execute the code immediately, or at least if you execute it in the same context in which you bind this x, y, and z. In another ways, you don't. However, Python has another feature that kind of undoes phenomena, and it is just the default values for arguments. So if you have an argument that whose first name is underscore, so it just says that it shouldn't be used in the ordinary way. It's kind of like private, and you pass this I as a default value of this argument, then it will, of course, this first functioning string will have a default value of underscore I as 0, and the second one will have a default value of underscore I as 1. Why? Because when you define functions, of course, I said functions are delayed code. This code is delayed. This one, the code for functions themselves.
Yeah.
And this line is not delayed. This line is executed immediately. This line is executed with the current value of I. Yeah, of course, this is also the reason why people don't really appreciate or don't really understand when you write I don't know, the f of a is empty list, and then you mutate it, right? You know that it is also in frequently asked questions, so it shouldn't be a surprise. So you define a function, and then you call a function, and you get a list with only one argument. But when you call a function again, then you will get the same list, but it will now have 2 ones in it. Why? Because it is the same list. It is just written as an attribute of f. And this is just the same all the time. It is the same object. Why? Because this assignment, this binding of this to a default argument of a is executed only once. It is executed when f is defined, and this code that appends 1 to it is executed every time that f is called. People usually think that this should also be executed every time that f is called, but it is wrong. The indentation says otherwise. This is not indented. This is indented, right? So when you write I don't know, for loop, and then you do something, this loop, this do something will be executed 5 times, but this range will not be executed 5 times. It will just be constructed once, of course. So it has to be like this for Python to be consistent. But if you need to have this assignment executed every time def is called, it is very simple. You just indent it. You say def f of a is something else, for example, none, and then you in the code you say if a is none, then you do whatever you need to do. However, in this case, this is part of the code of function f. In this case, this is not part of the code of function f. This is part of initialization. This is just an attribute of f, right? And when you understand that this some things are data and some other things are code, it becomes much easier to understand.
Yeah.
Okay.
This is probably one of the first mistake you probably do when you start coding Python. Was this?
Yes, I'm not quite sure. I think it is quite connected with another mistake that people coming from C or in some cases Java, but mostly C do usually, or C++ probably. When people have, I don't know, A is a list. And then they try to mutate it, but try to preserve the original value. For example, a original is a, and they think it is now safe. Then you mutate a, I don't know, clear, and do something with it, and then in some case you want to undo it, and then you return the original value of a, and you are very surprised that it is cleared. However, you haven't copied anything. You have just named the same list with two different names. And once you understand this, I really think this is the first error if you're talking chronologically. And once you understand this, you should really understand that this is not much different, right? This is just the idea of when statements are executed. So this which is not indented is executed only once, and this which is indented is executed many times, as many as you call the function. Okay. One more thing, I said that these closures are one thing that bites people when they try to define functions in the for loop. There is one more thing, and that is a name. You see, I have defined this function. I have named it extreme. I cannot really name it min or max because I cannot use this name as a variable. If I was writing, I don't know, Perl or PHP, I would probably write something like this, or probably something like this. So define a function whose name is not really name, but it is whatever is contained in the variable name, right? So its name must be dynamic. And you cannot really write it in Python this way, because when you define a function, you have to write some here, and this will just be the name of your function.
Right? Yeah, the same as with.
But of course, it's not really hard to do. You just need to understand what are you doing, because it is a nice analogy with. There was some story about. What is the name of this cat? Because when you try to write some analogy with, for example, names of animals, then you understand that animal might not have a name at all. It might have two different names. Any man or any person that knows that animal might call it with a different name. So the name is not really a property of an object. It can be a property of an object, of course. Python has many objects that know their names. For example, this f function that I have defined recently, it knows its name, of course. F is just f. However, if I define a name for a number 5, then this a simply doesn't know that it is called an a. Can be called any other things. It can be called b, and it will just not know its name at all. Of course, I can also name that f by another name g. However, g also knows its original name, after which it was named originally, and it is f. The objects, functions, classes, and some things like those objects that are named some blocks of code, they usually have this attribute under name. However, simple objects like numbers, strings, or something like that, in many cases don't really know anything about their names. So what is a name? Name is a feature of a namespace. In every case, you have current variables. So, of course, here are many variables in this default namespace, and they refer to some objects. And what do I need to do after I define this function? I just want to say that it should be referred in the globals namespace, in the namespace of this module that will be executed in check.io by the name. So I just insert this function into globals namespace under the name, and it will be just called this name. Of course, so I can write vars under the name blah, this function f, and it will be there, of course, but it will not be in some other namespace because I have put it just in this namespace, right?
Yeah.
So the name is not a property of an object. It can be, but it's not necessarily a property of an object, but it is necessarily a property of some namespace. You have many namespaces in Python. You have Dunderdict of some object. You have globals. You have locals. You have I don't know, local variables in a function. You have enclosed variables in the closures, and in all of these namespaces, you have some rules about what can be names, how they can be bound to objects, and so on. So if you work by those rules, you can, as long as you obey those rules, you can treat all those namespaces as simple dictionaries. So you refer to this dictionary, you set this item name to something. Of course, this extreme function, its dunder name is still extreme. It doesn't know anything else. But in the globals namespace, it is named min. And another function that also thinks its local name is extreme is in the global namespace named max. And it works.
I saw
Okay.
what I wanted to add to your about the naming. I saw in some decorators. So when you decorate the function, it's actually changed your name, function name.
Okay. Yes. Yes. There we have seen functools wraps.
Yeah, function wraps. Yep. So
wraps is one of those things that is really necessary because you really in many cases when you're writing a decorator, you don't really need to define another function. You just need to some kind of like modify the original function, right? Yeah. So you want to say decorate me this function G. So this function G receives something, it does something, it returns something, and inside this decorator, I really don't want another function. For example, function. What I really want when this is called with this G, I want to write some another function. Inside of which I will probably call some G and transform its inputs or its outputs or whatever I need to do more. However, I want this another function to be just something like an alias for this G or for this afunc, and I can do it with functools wraps. Of course. I will call it by this name. So once I execute this definition, this function definition, its name will be G. Its internal name, the underscore name, and also its external name. It will be known by as G inside it, for example, the global namespace. However, when I execute this decorator, if I didn't write this functools wraps, then of course it will, once I return actually another function, this name G will just refer externally in the namespace where it was defined to another function. However, internally, this function that I know as G will think its name is not G, will think its name is another function, will think its signature is probably, people usually write args keywords, right? And this G probably has some more explicit signature, right? So when I inquiry this this function about its signature, it will not know anything about G. It will just know about its signature here. So functools wraps is a kind of a workaround for this mechanism when you say, I'm aware that this function know anything about the external world in which G was defined. So I want this another function to actually assume the identity as much as it can from this function it was called on. So G is probably smarter about the signature, about its name, about its various other metadata than this function, another function. So I want another function to really forget its own ideas about its names, about its arguments, about its return value. I just wanted to execute some code around this function, but I want its identity as much as possible to be the same as G. For example, one other thing, docstring. G can have some nice docstring.
Yeah.
But of course, if I didn't write these functools wraps, then after I execute this, help of G will give me nothing, because it will just execute help on this another function, and it doesn't have a docstring. It can have a docstring, but it cannot really understand what function it was called on. So this decorator is really essential for connecting those two functions or transferring those metadata from one to the other.
Yeah. Another
so
example.
yes, you can change the name. You can just, for example, this F. I can say its name is. It probably doesn't even have to be a valid name. It can be a weird name.
Yeah.
However, okay. So it has also something called qual name, which is not really only its name, but also the module in which, or the class in which it was defined. So the qualified name. Okay.
Yeah.
So, of course, it's not meant to be used that way, but of course, I wanted just to say that this attribute is writable. You can write in it whatever you want, and this functools wraps uses it to copy metadata from the real function to the wrapped function. Okay. So AST, right? What about AST? It is probably the only really interesting in the context of track.io thing from AST is literal eval. There, and what has it to do with with eval, and why people want to use it in this case. Memento 140.
It's the old when this mission was score game, when you need to create the shortest mission as possible.
Ah, yes, of course.
Yeah, we have this comment.
Yes, I remember. So yes, this is one of those things when you really need to use standard library in some nice way, and it helps if the name of the module is really short. So AST has only 3 letters. However, the literal eval is long, but what can you do? And what it does, of course, let's just speak something about the eval function. You can eval anything. You can eval strings, mostly strings. When you contain some expressions in them, you can just push them into a Python interpreter and as expressions, not as statements. So you cannot eval a for loop or something like this. This will not work because it expects an expression. Of course, you also have exec, which is like an eval sum, but for statements. So you can exec strings like this, and it will just do the ordinary thing. However, in many cases, you want some kind of functionality of eval, but not for arbitrary expressions. Arbitrary expressions are weird. For example, this is an arbitrary expression. I don't know.
It works.
For example, if you are on Windows, of course, it will not work in modern operating systems, but you can really write anything here. This is just a function call which Python interprets as an ordinary expression and doesn't really care about side effects. Side effects can be anything. But people usually don't need that much of liberty. They need only here to have some literal. So literal can be many things. It can be a string, it can be a number, it can be some more complicated literal like a display. For example, this is what Python calls a display of a list. So it is just a serialization of a list or a tuple or a set or a dictionary or something like this, which really shouldn't and doesn't have a side effect. And of course, you can do some whitelisting or blacklisting by trying yourself to collect some common cases while forbidding another uncommon cases that might be dangerous. However, Python standard library must know about all those things because it does them, and it constructs from, I don't know, you have some kind of bytes on disk, then you decode them, then you have some text, then you tokenize it, then you have tokens, then you parse them, then you have a parse tree, then you convert that parse tree to an abstract syntax tree, then you convert that abstract syntax tree to a bytecode, then you optimize that bytecode into optimized bytecode, and then you execute it on a virtual machine, and then you get some output. So Python passes through all those phases in while it is executing your code. So it knows in this moment when it has constructed a parse tree, and it needs to convert those literals in the parse tree to concrete Python objects. It must have some function like this. Of course, this function cannot really be eval, because in this eval you have the whole. You would get an infinite recursion, because to implement eval you need to have all these things from the beginning to the end. Of course, not really, but from this. Yeah. Eval accepts a string. So you need to have some kind of a function that takes some leaf of a parse tree and converts it to a Python object. And that is really a function which is exposed in Python AST as a literal. So it is not really a special case of eval. It is, but it is not implemented like this, because when you need function like this, you don't already have eval. You only have eval for literals, and it works nicely. It is just, so it is not a special case of eval. It is a building block of eval. You need it to really implement eval as is proper. Okay.
Okay.
So in this case, of
so
course,
it's
to flatten all.
So it's basically
Yes.
it's not only safe, but also should work faster, much faster than you just.
Probably yes. I haven't timed it, but yes, it should, because eval must in some in at least in some branches it must call literal eval. So of course, for example, I have written something like this. So this format C, this string inside it is literal, and you must in some at some point of your evaluation you must convert this string, this substring of your input string, to another string that will really be passed to the OS system call, right? Or to get something more interesting, when you evolve something like this, you need to have this substring, this one which is really a substring of the input to evolve, converted to a real Python number one, and this is what literal eval does. Of course, when you know about the types, okay. When you know about the types, it is much simpler and probably also much faster to use the dedicated function. If you know that this one is just int, then you convert it with an int, of course. But when it only works with those primitive values. If you have a display of something like a list, you cannot really say list. It will not work. It will work, but not in the sense you actually want it, because of course this string will be interpreted as an iterable of characters, and every character will be an element of your list. All right. So as you said, those are probably in 3-point circle. It's a nice. It's a nice mission for you using something like this, because the input is really a string that contains 3 tuples. So it is.
Yeah.
It just calls you to call literal eval on it. But of course, you again in this case you can really split it on a comma and the parenthesis or something like this, and then call literal eval on every one of them. But you can do better. You can just literal eval all this whole this string, and then just pick up those 3 points. So you can do I don't know. 3, 4, 5, 6. So this is your input, and you can literally eval it directly. So you can just say it will be a tuple, because of course those outer parentheses are not needed. 0.1, 0.2, 0.3. Okay, so 3-point circle uses it in, mostly. It is probably the same trick. I will not. But funny adding might be interesting. Of course, it can just use it as an eval, but maybe there is something more here.
I think we have one solution, funny adding, where it literally use everything that is possible to be used. I think this is the one. Yeah, probably this is the one.
This is. This is the one. Yes, yes,
Yeah,
yes.
I'm
It
actually,
it.
yeah.
I think I have seen it. It implements the whole. It really implements up another computer inside the computer, right?
Oh, really?
Yes, it is. It is just. I have said it as a reduction, as a ad absurdum. When you need to implement a val, you need all those things from bytes or text to tokens to parse trees to everything else until you get some output. And this author of this solution, which is really ingenious, has decided to implement everything of this transition inside Python. So it has a tokenizer, it has a parser, it has a microprocessor, it has its own bytecode, something like this. I think I have seen some expressions. It's really wonderful. It is really it has even flags. Like, of course, it's probably not necessary, but why not when it has everything else? So it's really writing Python's evaluator inside of Python, and it is really nice idea. However, I really don't see how they had enough time or enough nerves to do something like this.
Maybe it was part of some other projects before, and then
Possibly, yes. Of course, I shouldn't dismiss it so easily. You have probably heard about PyPy. PyPy is mostly the same idea. Of course, the name is Python written in Python. It's not really. It's in fact Python written in restricted Python. But this restricted Python is a language that is really nice, much nicer than C or Java or whatever people write Python in. And it has this wonderful idea that you already need to write Python in some language. So you have some implementation, and you just need to optimize it in a way that it will be refactorable. And once you do it systematically, you see that you don't, to implement Python, you don't really need whole of Python. You need some minimalistic subset of Python, which can be really optimized. And this is this R Python or restricted Python. Once you do this, and once you have a really strong and versatile compiler for R Python, then you write Python, the ordinary usual Python in it. And this is the idea of PyPy. And it works very nicely. People usually ask me, how can PyPy be more be faster than C Python when the implementation language is slower? Implementation language doesn't really matter. You pass through some optimization phase in which you explain to the compiler that it can optimize many things. And once you have a nicer language than C, you also have a language that is nicer and more susceptible to optimizations. So people actually do it, but of course this is not it. It just invents some kind of its own notations and. But yes, in kind of the same style.
maybe it's part of PyPy. No.
It is possible, but I haven't really seen the source of PyPy, so I cannot be sure. If it is, then it is just a tiny part, because it has, for example, it has some instructions that are really used in the bytecode of Python, but not all. It has probably only those that they need to implement the addition. It has binary add, it has pop top and return value and something like this. But somebody was really careful to pick and choose, if they did so, from the source of PyPy, and I'm not sure it was meaningful for them, because it is obvious that this solution was meant to be as long as possible. So they, if they had access to PyPy source code, they would probably dump it all here.
Yeah.
So what was the criteria for choosing? I'm not quite sure. So there is one more. I don't know if it is a hint, but look at the username. Maybe somebody is really trying to write an operating system in Python. If they did, this operating system would probably have a Python compiler, and it would.
Oh, it actually has a
have
name
in it
and URL.
some-
So maybe you see github/pyo/dg. So maybe it's actually.
Okay, I might check it out someday.
Yeah.
Compressed version of DG. Yes. Okay. It's. Let's see.
Yeah. So people can
Programming
literally.
language for the C Python virtual machine. Interesting. So he doesn't really write an operating system, but he does write a new programming language, which uses Python as an implementation language. Like for example, Jython is using Java virtual machine, right?
Okay.
It is Python written in Java. This is some other in Python. However, for example, obviously this language has the same syntax for addition, so he can use it in this case to just add two numbers. Right. Very interesting.
Cool.
Okay.
Cool use case, so people can promote their projects.
Yes, of course. I haven't really liked this. This is unforgivable. Why is it uncategorized? You see, this is why community should decide on a category, not the author itself.
Yeah, I remember your argument about your.
Okay. So this I'm really not comfortable with giving it 5 stars, because I have seen some atrocities like lambda x, colon x, or something like this. But the idea is really wonderful. So I will give it 4 pluses.
Yeah, unfortunately, we already run out of time.
Okay.
I was afraid that we don't have enough solutions to review, but we go so deep in some other modules.
Oh yes, I wanted to say that to you also. In some cases, you are quite welcome to stop me if you see that I'm going too deep into something.
I think I'm
sorry that we haven't had the opportunity to dissect that heap queue, but some other time.
I think yeah. We have some, and if some other our listeners or viewers or someone who will see this later, they might propose what other modules they want to review, or maybe their solution they want to review. Yeah, so
yes,
yeah, we as you can see, we go pretty deep and go some insights from even some what Guido likes or what Guido don't like.
Yes. I really, some people tell me that I have eidetic memory. I'm not quite sure, but I really do have a better memory than usual, and I remember all those things that I have read in the beginnings of my adventure with Python, when I was really reading one by one the posts from Python mailing lists, and that was at the time when Guido had much more time. He wasn't so occupied with many technical details like now of async.io or something like this. He was much more willing to talk about his insights. What is it? Of course, people were reading it. Many people were reading it, but I think I have remembered most of it, and I can now relate back.
Yeah, I have so bad memory. That's just terrible. So I was always jealous for people too.
Yes, it is kind of depressing when you post a new mission and then I say to you that yes, there is a function that I was just reading about it 3 years ago and I just remembered it. But yes, it's all part of life. Okay.
Thanks a lot again for helping us and for being with us and explaining all the insights. Hopefully it's not the last time. We will see again. And
of course not. Okay.
Some other things. Bye.
Yeah.
Thanks.
Bye.